Just suppose you have one XY plane like this, something like that, and this is going to be, say, some kind of,
No, I'm not having any problems.
okay, yes. Should I continue?
Yes.
Okay, just try to focus here. This you may consider as this is going to be your radius there. What you need to do, you need to just rotate this radius about this x-axis. So when you rotate this, so there will be, when you're rotating this about x-axis, and this will be the situation. Am I right?
Right.
So just suppose instead of this single line, there was a rectangle, and I ask you to rotate it about the x-axis. So this will be the situation. It will not be the same structure, but yet it will be a 3D figure. Do you agree?
Right.
So these are the type of things we are going to consider here. There may be a straight line, or there may be a curve there. When you are going to just rotate about the x-axis, there will be a similar image, and you will be able to get a 3D image. Based on that, we will be finding the volume of the whatever the structure we will be obtaining using this. Is it clear to you?
Yes.
It is depending upon the curve given to you, what kind of situation we will have. Another thing, both the question I told you that I'm going to rotate about x-axis. You can ask me just rotate about y-axis, what will be the situation? Or you can give me another situation like this is another axis, say y equals to x. Rotate this line about y equals to x. What may be the volume of that curve? So some of the questions we will be discussing will be based on the same. Okay. For the
Okay.
moment, let me just ask you the simplest question. What kind of figure you can see in this case when it was just a straight line, something like that, and when you rotate it, do you think it is going to be a cylinder?
Um,
This
it
figure
should
is
be.
it should be a cylinder, although the figure is not so accurate, but yes, it is a cylinder for you. What is the volume of cylinder? The volume of cylinder, as you know, it is going to be pi r square. R is stands for the radius and multiplied by h. H is the length there. For the moment, this length is going to be h for you. Okay.
Okay.
So if you can bifurcate these things, this pi r square, it is nothing but it is the area of the cross section. If r is the radius, and if I ask you what is the cross section, it is going to be pi r square. Agree?
Yes.
I hope you know about the cross section. If you don't know, I'm just giving you an example. Take a boiled egg, just cut it with the knife. Whatever the surface you will get, that is going to be a cross section. So whenever you just have a cut anywhere perpendicular to the x-axis for the moment, whatever the surface, it is going to be a circle. This is going to be the area of the cross section multiplied by h. We'll be using these type of concepts, and it is the simplest case. Now, in the later on case, when you, for example, in this situation, there is no h like this. It is not a straight one. Okay, so we need to
Okay.
make use of integration techniques to just find out the volumes. Okay,
Okay.
so the first method we are discussing here is we call it a disk method. In the disk method, sorry, yes, in the disk method, the volume is given by volume of the disk is given by what I told you, like area of the disk, that is the cross section multiplied by the width there. Clear term? Now,
Yeah.
be- because what I told you, we will not be able to get the cylindrical format. So what we may expect? We may expect a curve like this. This is your initial curve. You may consider this curve as x-axis. Okay, like the values of x are given to you. When I ask you to rotate about the x-axis, so this is how you will rotate. Check. Try to focus when you are rotating this one about the x-axis, this kind of shape you will get, and this shape will be in 3D. Am I right? So from 3D,
Right.
we are getting a shape in 3D. Question, what is the volume there? In order to get the volume, now just try to focus on this strip given to you. When you rotate this strip, this is going to be the strip after rotating this representative rectangle. Now, whenever you are rotating with respect to x-axis, if you ask me what is the volume there, the answer is going to be, I told you it was pi r square. The length of this structure is going to be your radius. The length of this structure is going to be your radius there. How can you find the radius? A task is simple. This is the curve y equals to fx for the moment. At this point, just suppose this is my x there. This height is represented by fx. So for you, the radius is going to be fx there. Any doubt?
No.
Remember again, whenever the curve y equals to fx, if I ask you, tell me about the radius, you will tell me it is going to be fx. So I'm writing pi r is r, okay, multiplied by h. See, h was earlier, it was a constant, but right now it is going to be a variable term. And because it changes when x moves from left to right. So we need to add the integration. So I'm just adding the integration a to b and dx. So this is the formula whenever the disk is there. And remember, I'm rotating with respect to x-axis. This is the formula you need to learn. Okay. Similar kind of formula can be obtained when you are just moving. Sorry, when you are just rotating the strip with respect to y-axis. So let me just tell you about that. These are the two formulas you need to know for the moment. I'll explain them maybe later on with the help of the examples. Okay. So let me just take you with an example and just try to observe what kind of shape we will be having and what kind of formula we will be using. Whenever we are rotating with respect to x-axis, the horizontal axis revolution, this is the formula. And then whenever vertical rotations are there, we will be having the second formula. Look at the question, please. It is going to be square root of sine x. Sine has the value from 0 to 1. So if you ask me what type of shape I will be having, so I will tell you, and this type of shape I'm expecting from 0 to pi. Am I right?
Right.
Perfectly. Okay. This is the square root of x there. Okay. So I have got the limit of x, and the question is solid form by revolving the region bounded by the graph above and the x-axis about the x-axis. So which formula I should use? I should use the first formula. So for the first formula, this is my y equals fx for you. At any moment, I will be using a strip. We call it a strip. Okay, this is strip helps me in finding the rx there. So if I ask you what is your rx for any point x there, the height is going to be your rx. What is the height? It is going to be square root of sine x there. So tell me about the volume. Volume is going to be pi, which is a constant. Keep it outside the sign of integration. Just write 0 to pi. These are the limits of x given to us. And I'm having rx square into dx. What is Rx square? It is 0 to pi. Sorry, it is Rx square is going to be over sine x. And you know the integration of sine x. What is the integration of sine x? Is it negative of cos x?
Right.
And you can simplify. Can you please tell me what is the final answer?
So, that would be pi, negative
Just
cosine pi, which would be,
cosine
0,
pi.
then
No, 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 no.
minus,
Wait, wait, wait. There is a catch. You missed the statement with the logic. Cos pi is going to be minus 1. Okay,
Okay.
this is how you should read, right? Cos pi is minus 1 because minus is already there. So it is going to be positive 1. Cos 0 is positive 1. The answer is going to be 2 pi. This is how you should be able to write the answer. Okay.
Okay.
So let me just share with you the figure. They are posting the figure. After revolving this curve about the x-axis, this type of shape you will get. This is a 3D shape. I will not be able to draw it exactly, but I'm using a 2D shape to get the volume. But yes, if you wish to visualize, this is how it will look like. Okay.
Okay.
Okay. So the only thing we will be discussing, yes, later on there will be some more methods to get the volumes. Right now we have only this one. Okay, let me just take you to the next question. And this is going to be our coordinate axis revolving about a line that is not a coordinate axis. Okay, just try to help me. Read the question carefully and let me just try to plot the graph. So find the volume of the solid formed by revolving the curve 2 minus x square. Remember, 2 minus x square. Is it a quadratic equation?
A quadrant?
Is it a quadratic equation that is parabolic equation of degree 2? It is a polynomial of degree 2. Am I right?
Right.
Perfectly okay. What type of shape will it may have? Quadratic or parabolic shapes of quadratic or parabolic function have the shape either U shape upward or downward. So upward shape is going to be whenever the coefficient of x square a is positive, then it is upward. Whenever the coefficient of x square a is negative, it is going to be downward. So let me just first tell you what kind of graph we will be having. If you ask me, there is a function x square. What is going to be the graph? I will tell you like this. Then you may ask me, what if I'm just having negative x square? Because of negative x square, you need to just shift the graph downward. Any doubt there? You got the graph of negative x square?
Right.
In the third statement, like hx, you asked me, just add 2 there. So whenever you are adding 2, just suppose this line is representing y equals 2 there. What I'm asking you, shift the graph by 2 units upward. So I'm just shifting the graph by 2 units upward. So I'm getting this type of graph. Any doubt?
No.
So you got the idea. So what I'm going to plot here, this is the type of graph I'm expecting. Any doubt? This is the graph of
No doubt.
fx equals 2 minus x square. Another thing, there is another graph gx equals 1. Gx equals 1, it is nothing but a horizontal line. Gx equals 1, it is a horizontal line to you. So you need to rotate whatever the area bounded by these two. What is the area bounded by these two? Let me just try to tell you. This is, oh, sorry. Yes. This is the area bounded by these two. You need to rotate this area with the horizontal line y equals 1. Whatever the shape you will get, we need to find the volume. So let me just try to paste the figures for a better understanding. This is the first figure given to you in the book. And after revolving about the line y equals to 1, try to focus. This is the shape we are expecting. We need to find the volume when we are rotating this curve about the line y equals to 1. You can see the maximum point is going to be 2, 0. The maximum point is going to be 2, 0, or 0, 2. This is going to be y equals 1. So when you're rotating, so technically this is going to be the lowest point. So this kind of graph we will be having. Any doubt?
No.
Now the question is how we can just try to find the volume. I do have the same method, that is the disk method. In disk method, what I need a just radius. Can you please help me if I take a vertical step like this? Vertical step like this. At any point x, this radius I need to know. What will be the radius?
It'd be the integral of
No, no,
2
I'm just
minus.
asking about the, I'm not asking about the volume. I'm just asking you about the radius. What is going to be the radius?
Oh, it would be 2 minus x squared
Let me,
minus
yes,
1.
you are perfectly
So
okay.
1 minus
Always
x squared.
perfectly okay, perfectly okay. Always remember, whenever you have vertical strip, remember the case top minus bottom. Okay, so if I ask you again, what is the top curve? You will tell me the top curve is this with the yellow line. It is 2 minus x squared. What is the bottom curve? Bottom curve, as you know, this is the line gx equals 1. This is going to be your radius. Always top minus bottom. So now I have got everything. If I ask you what is the volume there, in the volume you will tell me the pi, the point of intersection from A to B, which I do not have for the moment. My Rx square dx pi is there. I will try to tell you this A to B. What was the Rx? It was 2 minus x square top minus bottom. You get the formula top minus bottom?
Can you repeat the question?
Okay. My question was, see, I need to find the radius because whenever you are revolving about the axis, you need the radius there. For getting the radius, we need a strip, like they are having a strip here. The question is, what is going to be the radius of the strip? Because in volume, we need the radius. The radius is always going to be, look at the top curve, look at the bottom curve. Radius is going to be always top minus bottom. Any doubt?
No.
Perfectly okay. But one more thing left. If this is not relevant to you, let me just erase this. Okay, the only thing left here is I somehow need the limits of x. So there were two curves. One curve is fx equals 2 minus x square. Another curve was gx equals 1. I need to get the point of intersection. Point of intersection, that means these points I need to know. This is my point A, this is my point B. These are the points of intersection of these two curves. How can you obtain these the values of x? It is simple there. Just equate fx equals gx there. These whatever the solution, the x values are going to be the limits for us in the volume case. So I'm just asking you to equate them. Just try to help me. X square is going to be 1. Do you agree?
Right. Then x would
And that means
equal 1 as well.
plus, plus minus 1. Perfectly okay. So the limits I was talking about, A to B, A is going to be minus 1, B is going to be 1. Agree?
Right.
So now it is a simple question for you to integrate from minus 1 to 1 of this 1 minus x square whole square. Now it is a
Okay.
basic and simple task for you. A square plus minus 2ab, and I hope and now you can easily simplify this. I need now to further invest time here. Agree?
Right.
So in this question, we have revolved about a line which was parallel to the x-axis. Okay, and the key part is how to find the radius. Radius is the key part. It is top minus bottom. Okay.
Okay.
Okay. And the next question is this is going to be the washer method. Actually, this method is the same. Whatever we have learned, it is almost the same. And you will find this. Check the situation. Axis of revolution. So, like we had the situation where there was a top curve, there was a bottom curve, and I told you how to find the radius. And I told you how to find the radius. You told me the radius is going to be top minus bottom. Am I right?
Right.
This was the situation there. We had a similar situation, not exactly the same, but yes, a similar type of situation we will be dealing here. So, how the question will look like? Just try to first focus on these two images and try to understand what is the difference between the disk and the washer method. This is the curve given to you. You are going to rotate. You are going to rotate about the x-axis. So you will be having situation like this is a line, vertical line, and curve like this. And because we are just rotating about the x-axis, the inside portion is going to be hollow. So whatever inside, this is going to be a hollow figure. Right there.
Right.
Now the question is, can we apply the disk method here? The answer was no, because in the disk method, there was a curve, a single curve. We were rotating it about a horizontal line. Now we are rotating a region. Okay, we are rotating an area about the x-axis. So we cannot apply the disk method. Now the question is, what is the formula for the volume? The answer is going to be, we'll talk about the volume of the outer. We will talk about the volume of the inner. Outer stands for, I'm going to rotate about the x-axis. Choose any point, say x, go to the top. This is going to be the highest radius you can have corresponding to a point. This we denote by Rx, capital Rx. Similarly, you just choose the same point, consider same point, and you just try to get a radius with the lower type of function. This is going to be your small Rx. What the suggestion is, if I just try to write integration a to b dx, this will give me, using the disk method, the area bounded by this curve. So volume bounded by this straight line. Minus, when I subtract, sorry, I forget to write square there. My bad. When I just take the small radius, Rx, this will tell me the volume bounded by this lower curve. You just take a difference of them. This is the washer method. So remember one last time, let me just tell you how the situation goes. This is x-axis. You have a straight line. Then there is a curve. Choose any point. First of all, you need to choose a vertical strip. Vertical strip will tell me what is at the top, what is at the bottom. Clear? So what is my capital Rx? It is nothing but whatever the function at the top. What is my small rx? It is whatever the function at the bottom there. Clear term? Washer method will tell you what is the volume. It is going to be pi integration a to b. What is a there? A is nothing but the limits of x. And you
Um,
can do the same and similar case with respect to the y-axis also. Okay. You get the difference between the washer method and the disk method? Maybe no.
yes.
Okay, even if it is a no, so we will be having example. Just try to understand. Okay, first of all, and see in these type of questions, drawing a basic graph in 2D is going to be important for you. If you're not able to draw the graph, you will not be able to understand. Just try to assume there are two curves given to you, y equals to square root of x y equals to x square. What kind of graph they will be having? Yes, y equals to x square is going to be like this, and y equals to square root square root of x is going to be like this. So this is the area, and you need to rotate this area about the x-axis. You got it?
Right.
Now, if you ask me what is the top, what is the bottom, I will ask you to take a vertical strip. In the vertical strip, you can easily tell me what is at the top, what is at the bottom. So if I ask you what is the capital Rx, you will tell me it is the top curve. What is the top curve?
Square root x.
Small rx stands for the bottom curve. What it is? X square. I need the point of intersection. I need the point of intersection. For point of intersection, you just equate the values of y. So square root of x is going to be x square. Just take the square both sides. It should be 4 there. I can rewrite the statement like x power 4 minus x equals 0. You can take x common, it is x cube minus 1. Can you please tell me what are the values of x for which the left hand side is 0? One is 0, other one is
It's 1.
no confusion there. So you have got the limits also. So now apply the Washer method. Washer method will give you the volume. It is going to be pi time limit from 0 to 1 capital Rx square minus small rx square dx. Okay, we are rotating about x-axis. So this is the formula. Just plug the values 0 to 1. It is the square of square root of x minus x square square. I'm just doing one more step. Square root of x whole square is going to be x. X square whole square is going to be x power 4. You can easily calculate the volume. Can you please tell me what is the volume there? Use your pen and paper, try to solve. Use your pen
Okay.
and paper, try to tell me what is the final value. What is the final answer?
It should be 4/5 minus 1. So that'd be negative 1/5 pi.
Oh, sorry, I think there is a issue in the calculation, or there will be issue in what I learned. Uh, if you integrate x, it is going to be x square by 2. If you integrate x power 4, it is going to be x power 5 by 5. From 0 to 1. So when you put the upper limit, it is 1 by 2 minus 1 by 5. When you put the lower limit, it is going to be 0 there for both the cases. And the final answer, I hope it is going to be 3 pi by 10. It is just a simple calculation for you. Right?
Right.
So just for the sake of understanding the images, I'm just pasting two graphs. This is what they have done in the book, and we have just followed them. This type of shape I have obtained earlier. When you revolve the same about the x-axis, this type of 3D figure you will be getting. Inside there is a hollow part, but if you can see, this is type of 3D figure you will be getting. Okay, and we have obtained the volume of this 3D figure using the partial method. Clear? And the basic idea is you should be able to draw the graph on 2D plane, XY plane. If you are not able to draw, then there will be an issue.
Okay.
Okay, so let me just take you to the next question. See, we will be having different type of questions. I will upload the figure maybe later on. Just try to draw the figure, try to understand the figure with pen and paper. Find the volume of the solid formed by revolving the region. Just a second. जल्दी संभाल लो और बाहर निकलो बेटा, क्लास में हूँ मैं। बेटा मैं क्लास में हूँ अभी अभी जल्दी संभाल लो, बाहर निकलो अभी। Quick. So just few seconds, David.
Okay.
Quickly close the door quickly. Viraj, properly close the door. Yes, sorry, David. My kids were there in the class, in the room. So, okay, let us just try to focus on this. You need to draw the graph first. Let me just try to draw. There is a line, there is a curve y equals to x square plus 1. Again, what it is going to be a parabolic shape. If you ask me to plot it, x square is going to be a parabola. Am I right?
Right.
This is what I told you. Yes. Give me a second. Yes. And now when you add 1 there, and let me tell you, this is going to be 1 for you. What it stands for, you just shift the graph by 1 upward. This is the graph of y equals to x square plus 1 you will get. First observation clear? Second is going to be y equals to 0. This is the graph of y equals to x square plus 1. Y equals to 0 is nothing but your x-axis. X equals to 0 is this line, and x equals to 1 is going to be this line. This is a vertical line. It will be representing x equals to 1. The question is, what is the area bounded? What is the area bounded? So if you just look at the graph carefully, so this is the area bounded by all the curves given to me. Agree?
Right.
So I need to rotate this graph about the y-axis. So that means to say that there will be a similar image, like this is going to be your x equals -1. And when I will be rotating, I need to add some kind of graph like this. I'm not good there, but let me just give you the idea how it will look like. This will be the shape we will be having when you rotate about the x-axis. Okay. So
Okay.
when you rotate about the y-axis. Now the question is, how can we find the volume of this type of structure? Okay. So for the moment, just allow me, because this line is representing 1 there. This is going to be y equals 1 there. Can we somehow have the top limit there? What may be the point of intersection here? For this, allow me, let me just equate y equals to x square plus 1 and x equals 1. Not equate, let me just put there. Put x equals to 1 in the given curve. What is the value of y you will get? 1 square plus 1, that is 2. Am I right?
Right.
That means to say that the top limit is going to be y equals 2 there. That is why this is 2, this is 1 given to you. So in the lower part, if you see this lower part, if you rotate, it will look like a cylinder for you. From what point? From 0 to 1, it is a cylinder. Am I right?
Right.
And in this top part, it is going to be hollow structure, hollow from inside. So I will be getting the area of the cylinder using a different formula. And for the upper part, I will be using washer method. In washer method, whenever you rotate or whatever the axis, you need to first talk about the strip. Because I'm rotating about the y-axis, my strip is going to be perpendicular to the y-axis. Any doubt there?
No.
So for the volume part from 1 to 2, I need the radius there. So always remember, whenever there is a horizontal strip like this, for the washer method, you can find out what is the left curve. You can find out what is the right curve. You need to tell me the curve in terms of x equals fy and right curve x equals gy. This is how you will tell me the curve. What will be your r? This time ry is going to be the right side curve. Any doubt? The capital R is going to be the right side curve. What it is? It is gy. And small ry is going to be the left side curve. What it is? Small f. Oh, it is going to be fy. So these are the changes you should be able to have. Let me tell you once more. Whenever we are rotating about the y-axis, we need to take a horizontal step. Okay. And how will you identify what is the capital R? It is the right side curve. So what is the right side curve? You can imagine. What is the left side curve? It is going to be small rx. Can you please help me? What is going to be your right side curve?
It's going to be
This line.
yes.
And this line is x equals 1. So as per this observation, this is going to be the right side curve. Left side curve is going to be, please help me. Y equals
It's
to
going
x
to
squared
be
is a, yes, it's going to be, what should I write there?
x equals the square root of 1 minus y.
Okay, and it is going to be positive because I am on in the first quadrant. X is going to be positive in the first quadrant. So this is 1 minus y there. No confusion?
And no, that's not
So,
confusing.
so the volume is going to be, now let me just go to the next page. The volume from 1 to 2 actually, from 1 to 2. It is going to be pi ry square minus small ry square dy plus. What is the bottom part? Bottom part is from y equals 0 to 1, and I told you it is a cylinder. I told you it is a cylinder, so you can simply apply the value pi equals to, oh sorry, you can apply the volume formula for cylinder, or if you wish to use the integration, the similar method, I can use the disk method there. The limits are from 0 to 1, am I right?
Right.
Limits are from 0 to 1. What is our radius there? The radius, if you take a strip, horizontal strip again, only right part is there. What is the right part? It is going to be 1. This will give you the right hand side. Simplify. I will getting pi 1 to 2 ry is 1 minus 1 minus y. Let me just put in the bracket dy. The other part is 0 to 1 integration of 1 dy. Can you please quickly take 2 minutes, simplify this and send it to me if it is possible to you? Yes, whatever you can have. Just a second. Have I made a mistake? Oh, there is a mistake. There is a mistake. It is going to be, it is going to be y minus 1. It is y minus 1. So that is a mistake from my side. Sorry, I am correcting this right now. It is square root of y minus 1. Find it out. Just take 1 minute.
No.
Just take 1 minute, calculate them, and tell me the final answer if it is not an issue with you. And I hope I told you how we have calculated the volume here. Okay, just take your time. Try to tell me the final answer. Just a second. The answer is going to be 3 pi by 2. Should I explain you how?
Oh, right.
Okay, so this is going to 1 to 2. Is it going to 1 minus y plus 1 dy? Just open the bracket. Integration 1 is going to be y here with the limit 0 to 1. You just try to simplify. Is it going to be 2 minus y dy
Right.
plus pi? Uh, just substitute the values. Can you please help me in integration? The integration of 2 is going to be 2y. Integration of
2y
y is going to be y
minus
square by
y
2.
squared over 2.
It is 2y. Oh, no. Oh, there is a mistake from my side. Our range was from 1 to 2. That was the mistake. Yes.
Oh, right.
So that was the mistake actually. Let me just write down. This is going to, when you so plug 2 there, it is going to be 4 minus 4 by 2, that is 2. When you plug 1 there, how much would you get? It is 2 minus 1 by 2. So it is pi. 4 minus 2 is 2 there. 2 minus 1 by 2 is going to be negative 3 by 2. So when you simplify all this, let me just take 1 also. When you simplify all this, I hope you will get 3 by 2 pi there without any issue. It is a basic calculation for you.
Okay.
Okay. Okay. So if not an issue, are you able to understand?
Yes.
Okay, that's good. So there is another question for you. Just try to help me in understanding the question. And in this case, we need to just make use of the figure given to us. Let me just paste the figure with you. So by looking at this, I'm rotating an area about the x-axis. This is what I can see. So I'm going to apply the Washer method. I'm going to rotate about the x-axis. You can see the sign. So the vertical strip will be there. So the top curve is going to be a capital Rx already given to you. The bottom curve, it is going to be a horizontal line y equals to 3 there. So if you ask me what is your small Rx, I'm going to tell you it is going to be 3. The question is, what is going to be the volume? For getting the volume, the answer is from pi a to b. Can you please help me? What is the lower limit?
The lower limit should be, hold on. Should
Just
be,
try to
negative
observe.
4. And the upper
And this
limit
is
should be 4.
perfectly okay. So let me just write down. It is from negative 4. Sorry. It is from negative 4 to 4. How much should I write?
Then r of x squared
Minus.
minus,
Now, the only issue here will be just plug the value. Rx is given to you within square root. So when you just do the square root will be cancelled. And Rx is going to be simple. So yes, I just squared this. Rx is going to be 3. So it is 3 square. Okay. Can you please take a
okay.
moment? Tell me what is the final answer in this case. Is it a
Okay.
difficult task?
Right.
No, it is not a difficult task. It is easy for you. So always remember you have two methods, disk method and washer method, whenever you are rotating about some axis. Okay, so just do a little bit calculation, try to tell me. And what I was telling you, whenever you are rotating, we have two methods, disk method and washer method, just remember. And if we are not rotating, we have different methods to find the volume. Yes, please, you got the answer?
Would it be
Yes, because every time the calculation is incorrect. So that suggests me there is some issue. So let me just write 25 minus x square minus 9, which amounts to 25 minus 9 is going to be how much? 16 minus x square. And if I ask you to just integrate, it is going to be 16x minus x cube by 3, with the limit from -4 to 4, right?
right?
Now just plug the values. The upper limit is going to be 16 into 4 minus 4 cube by 3. Lower limit is 16 into minus 4 negative 4 cube by 3. When you simplify this calculation, I'm expecting to have 256 divided by 3 pi. Okay, it is a simple calculations for you. Any doubt there?
No.
Okay, so there is another method. It is based on the cross section. We are not revolving about the x-axis. So I don't wish to go there. Let me just try one or two questions based on this rotation about the x-axis. Okay, so I'm just going in the exercise
Well,
part.
the answer you got, the 256 over 3, that's what I got. But like I got it as 85.33.
Okay, 84. Oh, sorry, I
And
get
there's the
it
pi afterwards
85
too.
there. Okay, then you are right. I am wrong. Sorry. I what I learned, it was 85 only. Oh, so that is why I told you this is wrong there. Okay,
Right.
so there are some questions like from exercise, if we can discuss from 1 to 6. Set up the integral formula. You need to only set up the integral formula. You need not to just simplify the question there. Uh, you are going to rotate about some axis. Okay, solid form by rotation. Let me just ask you to help me in the question number 5. This is the first question. I wish you to help me in the rotation part.
Okay.
The basic information, let me just give you using the curve. There are 2 points of intersection. Say first intersection point is A, another point is B. The x coordinate for A is going to be 0. The x coordinate for B is going to be 1 there. They have taken a vertical strip. This is the top curve, this is the bottom curve. There are two curves given to you. Can you please tell me which curve is going to be the top, which is going to be the bottom in 0 to 1? Do you have difficulty in identifying which curve is going to be the top?
Um, B
Tell
should
me,
be the
yeah,
top.
no. A and B, these are the points. There are two curves given to you. This is curve y equals x square. This is curve y equals x cube. One of them is maybe top, one of them may be bottom. Now, which one is top, which one is bottom? This is the question for you.
Oh, x cubed should be on the top, then x squared should be on the bottom.
Okay, the answer is negative here. In 0 to 1, in 0 to 1, and this x square is at the top, this is at the bottom. And whenever you have a confusion, just use a test point. Let me just ask you, let me take a point x equals 0.5. It is in between 0 to 1. Am I right?
Right.
The range. Talk about, check what is x square, what is x cube. Which one is bigger, that is at the top, simply. Okay, so you can identify which is at the top, which is at the bottom. I told you. So you got the idea how to calculate?
Right.
What is capital Rx? It is the top. Top is going to be like x square, I told you. What is the bottom? It is x cube. So now what is the volume there? The limits are going to be 0 to 1. I forget pi there. Capital Rx square minus small rx square dx, and that is all. You need to just set up the integral. Was it difficult task?
It's not difficult.
It is not difficult. Can you quickly just give me answer quickly
Okay.
for this question? Everything is with you. You need to dictate me what should be the formula for volume. Yes.
I haven't gotten the full setup thing yet. I'm still typing it out.
Okay. You are typing somewhere.
In the chat.
Maybe I will not be able to get the chat. I don't know why. This chat is not working. You can just dictate me. Oh, I think I'm getting a message from you. I'm getting a message. Thank you.
That
Uh,
wasn't my answer though. That was for the previous one.
okay, okay.
So it would be pi the integral from -3 to 3 of parentheses 4 minus x squared over 4 parentheses squared
Perfectly okay.
minus 4
Mine is perfectly okay. Okay.
dx.
Just quickly two more question and then you're free for the day. Just two
Okay,
more questions. So now you need to do the same, but this time you need to rotate about the y-axis. Okay, and here are two questions for you. And let me tell you, whenever we talk about the y-axis, you need to consider the function like x equals gy. If it is not in this format, just convert. For this question, just put 3 by 2 both sides. So x is going to be y power 3 by 2. This is the function you will be using,
okay,
right? That is the only thing I need to tell you. Otherwise, everything is same. In place of integrating with respect to x, we will be integrating with respect to y. Quickly help me with the answer for question number 9.
okay. So would that just be pi the integral from 0 to 1 of y to the 3 halves power dy?
Perfectly. Perfectly okay. Y power 3 half square
It's squared
dy.
dy.
Absolutely okay, no issues. Now tell me for the answer number 10. It is a simple formula.
So that would be pi integral of 1 to 4 of y squared minus 4y, and all of that would be squared dy.
Perfectly okay. So now because you are able to tell me what type of formula, integration formula, the next task remaining for you is going to simplify. Okay, so in the exercise, we just talked about 7.2. Wherever you get a question based on the revolution, I'm expecting you to try them as much as you can. There is one more method using the cross section. I will tell you maybe in the next class.
Okay,
Okay.